So let's look at your at-home experiments. While we wait for other people to show up to class, I'd like to show you guys some of the cool at-home experiments that your classmates have did. So here, let me make sure I'm sharing with, I'm going to share this with sound. Okay, so let's watch. Rose did an awesome job. Let's watch Rose's second video here.
Hi, my name is Rose. Today I will do an experiment. And here I have a hairbrush, a paper I cut metal, and a paper. First, I check the hairbrush. I put it in the box. It has nothing. Yes? And next, I will put it in the paper.
So Sarah, I'm really happy that you gave us materials. You told us all the materials we would need for our experiment, and now you're walking us step by step. First, she puts the hairbrush in without anything, just to demonstrate what happens with the hairbrush by itself. And now she's gonna rub it. Now she's gonna rub the hairbrush with her piece of paper.
And we'll make it hot. And I will put it down here. And you see has a little paper in here. Goodbye, everyone.
Great experiment, Sarah. Great experiment. Let me see if Sarah's here yet. Sino, make sure your camera is on. Blue Moon, Puppy, Emma. Make sure.
Can I have a video to watch? I have a very good experiment.
We can watch yours.
I also use comp like Rose, but I'm not using these sprinkles. I'm using a piece of paper that was lettering on the floor.
Oh, very cool. Sarah, good job, Sarah. Do you have anything else to add? Did you have fun? Anything else that you notice about the static electricity? Did you try this with anything else, Sarah? Did you try it with your hair or anything?
I took hair.
Did it work with your hair?
Yes.
You did? Okay, it was strong enough. It was strong enough. And did you try rubbing it on any other materials, or did you just use your piece of paper?
I just use my paper.
Paper, very cool. One thing you could have done, Sarah, is you could have done different materials. You could have found a piece of paper. Maybe you find a cloth. Maybe you use a carpet. Maybe a pillow. And you could test. And you could wait, Alex. Alex. Alex, not right now. So Sarah, yeah, you did a really good job. I really liked your experiment. It was a nice short video and it was concise. Very good job, Sarah. Okay, let's look at someone else's. Let's look at Alex's real quick. He says this is similar. So here's Alex.
Connor, but why when we rub the balloon into our hair and then it stick to our hair, what make that?
So when you rub the object, it is picking up electrons or electrical charges, and it makes it so your hair is attracted to the balloon, almost like a magnet.
But I think that's called a state electrically, like an electromagnet that is on the in the dimensions book. You see it on the next page.
Well, like when you rub something, when you rub the surfaces, it produces a charge. It's like you're making a magnet. It produces a charge. And then your hair has charges on it, and it gets attracted to the balloon. It gets attracted to the balloon like a magnet. But yeah, we'll look at it more. Let's watch Alex's experiment.
Okay. Today I'm at Alex. I have my con to use your steel electricity. They look like magnets because they can stick each other like a magnet. Aspect a thing. Here's the small part of paper, a cup, and a teddy. I will rub on this so I have to rub about more than 10 times so can get a full static electricity. I will do now. Before we is using a static electricity. It can't attract because it will have a static electricity like a magnet.
Good job showing us before.
I now have to rub and count. 1.
Oh, this thing's
2,
perfect.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23.
How many are you going? You're going for a lot.
25, 26, 27, 28, 29, 30.
Let's see if it. Oh, it picks it up. It picks up the pieces of paper now.
Down. Bye bye.
Great job, Alex. Good job, Alex. It's 30 times. Yeah, you did it 30 times. You did it 30 times.
30 times to make it more steady electricity.
Yeah, I bet when you get off, if you want to try it after this, if you want to make it even more static electricity, you could use the side of the comb. You could use the side of the comb because there's more surface. It's called surface area. There's more things touching. So if you were to turn your comb flat and do it against the bear, it would make even more. It would produce even more static electricity. You could test that out. But Alex, that was a great video. Good explanations. You showed us before. You showed us after. Okay, let's watch. Pasta's video was really good as well. Let's watch Pasta's.
I have a PVC pipe in my hands, and now I will rub it in this sweater, and the pipe will have static electricity in it. Static electricity is a type of energy that builds up on an object. If I rub this pipe for long enough and put it close to these piece of paper, the piece of paper will be attracted to the pipe.
And you can see how attractive that is. That PVC pipe is the perfect. It can hold a lot of charges. It can hold a lot of charges. Here you are. Here's Pasta. Hey, Pasta.
Hello.
Oh, there's Pasta. Good experiment. Good experiment. I'm glad you found the PVC pipe. Were you able to do anything else with your PVC pipe?
Yes.
What else did you do?
Another experiment at home, but I didn't remember it.
Okay. Were you able to pick up anyone's hair? Did it move anyone's hair, or did you do anything else with it?
I did. I remember that I used the PVC pipe and rubbed it on a bit on my father's hair and my mom's hair.
Did it pick up their hair? Did it make their hair stand up a little bit?
Yes.
Yeah, that's funny. That's probably like the balloon. Yeah, the PVC pipe was a really good choice. to hold on to that static electricity. You picked up a lot of pieces of paper. They were really dancing around. It was really cool to watch. Great, and a great explanation, Pasta. Your knowledge base is very good. So yeah, good job, Pasta.
Yay.
Okay. Let's watch a few. We're gonna watch a few more, and then we're gonna have to move on to our. Oh yeah, we can watch. Let me try. I'm trying to remember what everyone did. Okay, I think Jack Vu was gonna be next. Okay, so this is Jack Vu.
Hello everyone. Today I will try to make a static electricity. Now I have a plastic straw. I have lots of scrap paper. I have a floor tower. Now I rub the plastic straw to the floor tower.
I really like how you found fur, Jack. It's really cool.
It's a mom.
Jack Vu, make sure you have your camera on.
I stick now. Yeah. The scrap paper is stick on the plastic straw.
Oh yeah, there's paper all over it. Good job, Jack Vu.
Goodbye, everyone. See you next time.
Jack Vu, I really liked your experiment. I liked how you found just a plastic straw and pieces of paper. This is something that you could find at anyone's home. This is something you could find outside really easily too, and show someone this experiment. All you would need is a piece of paper and a straw, and then something to rub it on. Good job, Jack Vu. I really liked how simple you made it.
Please.
And then let's do Bunny. This will be our last one.
Hello everyone, my name is Bunny. Today I will talk about the science experiments. I choose to play the shark demos.
Yeah, if you guys watched the video, there was a shark demo or a shark game. And Bunny remade the shark game, which was really cool. Yeah.
On the demo shark. The materials is a tower, a piece of tissue.
Teacher, what videos is that?
This is the first video on my PowerPoint. This was my first video on my PowerPoint.
What's the sister's name?
I don't. This is Bunny, but
For the food into
but
the box.
this was on. So these are the sharks. Bunny's gonna explain it, and then we'll talk to Bunny afterwards. Let's just watch the video real quick.
Tape and of this box. So I have to I have to cut the tissue to little piece and cut the tissue into this ugly shark too. I will use the pen to stick it here. My dad has helped me to rub it with the tower.
And you can see that the sharks are attracted,
Little piece.
and the pieces of paper are attracted to the pen.
It stick on the pen. I know it stick on the pen because it create a little of the static electricity.
Good job.
What is the first thing
I will stick it with the
it
shark.
freezes?
Oh, it's so strong.
It makes
The shark is eating
what?
her pen. The shark is eating her pen.
Ah,
Uh-oh.
Why did the author write this story? To persuade the reader
let me
to
stick
make
on this
a
too.
bird
Very,
feeder. To
ma-
entertain the reader.
very.
Okay, let me find Bunny. There we go. Lucky Bunny and Sarah. Good job, Bunny. I really liked your video.
Are you sure?
Are you there, Bunny?
Yes.
Good video. How'd your dad make so much static electricity? What was he rubbing the pen with? What did he rub the pen on? On a towel. Okay. That was nice of him to rub the pen for you to make the static electricity. Was it fun playing the shark game?
Yeah.
Yeah. Were you able to pick up pieces of paper without being eaten by a shark?
No.
No?
No.
They caught you every time?
Yes.
Oh, the sharks were eating you every time. Uh-oh. That's funny. Yeah, this is a really cool game. If we go back to, I hopefully go back to class eventually, Bunny. Maybe you can help me set up this game. It would be fun. I think it would be fun to play with the other classmates. Don't you? I think that'd be a lot of fun. And we can see who collects the most pieces of paper. We can see who collects the most pieces of paper without being eaten by a shark. I think Mr. Connor would be eaten by a shark though. But good job, Bunny. I'm really glad you remade this game. I think this was my favorite part of the video. So I'm glad someone tried it. You're the only one that I saw try it. Maybe the other classmates did as well, but you're the only one that I saw that actually tried it. Good job, Bunny. Okay, guys, let's move on. Yes, Bunny? You want to say something? So we did your at-home experiment. Let's go back over pages 118 and 119 just to make sure. Let's just review our static electricity. Okay, let me pull up your book real quick. Oh, I don't think we ever made it to. We didn't really get to read this section, so I want to finish just page 119. 119. Okay. So if you guys get out your books, you can follow along. But let's read about 119. Let's have someone read the first sentence. The first sentence. Let's have Lisa. Could you read the first sentence for everyone?
Like magnetic force, electric force can act across a distance.
Very good. And who can tell me, what are they comparing? What are they comparing when you read this sentence? What are they comparing when we read this sentence? What two things are we comparing? Read the first sentence, everyone. What are the two things we're comparing? Comparing. Cherry, do you know what we're comparing in the first sentence? What are we comparing?
Can you say again?
Yeah, so in the first sentence, what are they comparing? Comparing.
My internet gas and spiral.
Yeah, so magnetic force and what else in the first sentence? You got one of them.
And electric force.
Exactly. And what word, Cherry, tells you that they're comparing them? Is it like? Is it can act across a distance? Which one tells you that they're comparing them? Which word? Do you know? So these are our two words we're comparing. Which word tells us we're comparing? What do you think, Cherry? What word tells us that we're comparing? let's see if someone can help you find this word. What word? Raise your hand. What word shows us that we're comparing? Who knows? Puppy, do you know? What words lets us know that we're comparing magnetic force with electric force? Is it going to be like, can, act, across a distance? Which one? Which one of these words?
Acting a distance.
Okay, it's not distance. I'm going to highlight all the words you can choose, guys. It is not distance. Let me call on someone else. Let's see if anyone can get this. Guys, type it in chat if you know it. Type it in chat if you know it. I can read your chat still. It's going to me and Miss Kimong. Let's see who can get it. Which one of these words? Type in the word you think it is. Type in the word you think it is. Which word lets us know we're comparing? Taylor got it. Taylor got it first. Taylor, what word is it?
It's the word like.
It's the word like, guys. They're using like to compare. Like magnetic force, electrical force can act across a distance, which means, Taylor, can they both act across a distance, or neither of them act across a distance? What do you think, Taylor? Can they both act across a distance, or neither of them can act across a distance?
I think both.
They both can, like a magnet. The magnetic force is like electrical force. Okay, let's keep on reading. Let's have Jackie. Can you read the next sentence for us?
And like magnets, electricity can produce a field, an electrical field.
Yeah, an electrical field. And once again, there's the word like. We have the word like again, comparing like a magnet, electricity. So they're comparing a magnet and electricity again. They're comparing electricity and a magnet again. Okay, Alex, can you read the next sentence? Alex, can you read the next sentence? Oh, it's a big sentence. Oh, it's only to here. Alex,
An
can you read this?
electrical field is the strongest nearest to the charged object.
And Alex, what was your charge object at home? What was your charge object at home?
That's iPhone.
No, during your experiment.
Experiment.
Yeah, you charged an object.
I rubbed the comb.
It was a comb. Yeah, it was a comb. You rubbed your comb. That was the charged object. That was the charged object. You charged it. You charged it by rubbing it. You charged it with negative, electrons. So the Van de Graaff machines, such as the ones shown below, make a field of static electricity. Now, these actually produce static electricity. They convert electricity into static electricity. You can plug these in. They produce static electricity. Okay. The attraction is strong enough to pull a charge across the gap. Look how much it can pull. Look at that electrical charge. That is static electricity. Okay, let's read the first picture. Sophia, could you read the first picture for us?
A shark jumps across an elastic fight when a step change reach and constant distant way.
Very good. And Sophia, can you say the word electrical field again? Electrical field.
Electrical field.
Good job, Sophia. And yeah, it can jump across that gap. That looks like it's about 5 inches, probably like 8 centimeters. That looks like an 8 centimeter jump. Okay, Let's have Blue Moon. Can you read the next image for us? Blue Moon, are you there?
Yeah.
Okay, can you read the second image for us?
How does the electrical field made by this machine differ from the field generated by the other machine?
Okay, how does the electrical field change between the first picture and the second picture? What do you think, Blue Moon?
I think second picture.
Yeah, how does it change? So this is the first picture and this is the second picture. What is different about the second picture? What changes? What differs from it? The word differ. What changes? How is it different? How is it different? Do you see any differences, Blue Moon? No? Okay. Raise your hand if you know what's different. Raise your hand on Zoom. I can see your hands. Raise your hand if you know what's different about these pictures. Anyone? Raise your hand. Who am I going to call on? Does anyone know? What is different about these pictures? Cherry, Sino, Ben 10, make sure your cameras are on. I can't see you. Sino, what's different about these pictures?
In the first picture, there is a spot to a ball have a spot to another object, but the second picture is to using a spot to
Yes, Sino got it. It is stronger. The second one has a stronger electrical field. Look how far that travels, guys. Look how far this electricity travels, the static electricity. It's traveling really far. So the electrical field is much stronger on the second picture than it was on the first picture. Good job, Sino. Okay, and let's answer question 15, and then we will be done. Let's read it. The Von de Graaff machine causes blank to build up on an object. What is building up on our object? Sarah.
Static electricity.
Exactly. Static electricity. This is like you building it up on your comb, Sarah, during your experiment. This is like you building it up on your comb. Static electricity. When opposite charges come in contact, you may see a blank as the charges cross the gap. What might we see? Let's have Zook. What might we see when opposite charges cross or come in contact? You might see what?
Might see.
Will we see a charged? Will we see repel? Will we see a spark? Will we see static electricity?
Static electricity.
Okay, we already used static electricity on the first one. Look at the pictures. What are we seeing? What is this? What is it called?
Spark.
It's called a spark. Good job, Zook. Good job. It is called a spark. So this is the answers for question number 15. Let's watch our generation video. So let me okay, they're going to talk about static electricity and something we're going to learn about next class. And they're going to talk about electromagnets. Who's using a magnet? She was using a magnet. She's holding a magnet and she's moving the pen. Okay, so there's tiny pieces of iron. This is the tiny pieces of iron and oil. What's going to happen to this what do you think is going to happen to this fluid
Stick.
with a magnet? What do you guys think?
I think it will stick. If the magnet come from closely, it will stick to the magnets.
Okay, it's going to stick to the magnet. So guys, if you took your iron filings, and added oil to them, you'd get this thing called ferrofluid. Ferrofluid is iron and oil. Iron and oil. So what things are magnetic? What do you guys see? What's common about all these magnetic things? What is magnetic about these
It has iron.
things? Rose, what do you think, Rose? What's something that all these objects have in common? Why are they all magnetic?
Have iron.
Yeah, it has iron or metal. It has some type of metal. Very good. So your homework is just to read page 120, one page of your book. 120, it's about electromagnets, and answer questions 16 and 17. 16 and 17.